Good evening. Happy Monday. Um, okay. Ah, yeah, let's do calls as an exercise. Oh, ugh. Ah, oh, oh. Wow. Okay. Okay. So let's practice some martial arts because use it or lose it, right? We gotta practice those things every once in a while. So, okay. Okay, the side kick, right? There we go. Okay, we'll take 5 minutes break. Please. Wow. Oh. Okay. Okay. Well, happy Monday, everybody. Um, uh, if you don't mind, let's do some mathematics, okay? Continuing from yesterday. Yay. Let's see. Uh, yeah. So, oh, let me turn on the heater real quick. Yeah, good evening, everybody. Happy Monday and Monday evening. So, we found something very cool yesterday. So, and later on, in my spare time, I realized that e to the minus x, uh, yeah, whatever, exponential function, it can be approximated with polynomials, right? Taylor series, Taylor expansion. Yeah. In my spare time, I was just, looking at some mathematical articles in the Wikipedia and then ran into Taylor series and then, oh, wow, yeah. Which I learned like long time ago. Taylor series, Maclaurin series, right? Yeah. But the thing is this, Maclaurin series is approximation when x is 0. Uh, e to the x is equal to something like at 0, okay? 1 x plus x squared over 2 factorial plus x cubed to the over 3 factorial blah 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 blah, right? So but that's good approximation when x is near 0. When x is like 5 or 10 or 100, you cannot use Maclaurin series at all. Why? Because then you have to use the full-fledged Taylor series, which is not too bad. But instead of putting x, you should put like e to the x minus 100, something like that. Okay, and the polynomial expansion, instead of just putting x, you should x minus 100 to the exponent. Okay, so that's the Taylor series expansion, and in this case, I don't know what that value would be, uh, because if we're gonna expand e to the n, approximate with some polynomials, we need to know where we want to approximate. Okay, what would be the value of n in this case? In that case, because we want that to be 0, we want this whole thing to be 0, right? That's the local um, minimum, local maximum. Um, So basically, what we found yesterday is that local maximum happens somewhere down the road, something like a minus 2 or a minus 1, or even later on. Okay, it depends on the value of a. If a is very big, then local maximum happens further down, right? Because we want this to be zero, right? What is this? It's the differentiation of the revenue function. Okay, the tangent. Okay, so derivative of revenue function. That's what we're dealing with here. Okay, so if this whole thing becomes zero, uh, okay, so this is what a looks like. So if a is a very big number, then n will be a very big number, right? That means a minus n, it will be very smaller, a lot smaller than number a. Okay, so what it means is this. Okay, a is the middle income. Okay, so if country is very rich, middle income people make a lot of money. Okay, then the profit maximization point goes further down. Okay, that's kind of what it means. Okay, and does that make economic sense? I haven't thought about that. Okay. Uh, well, what we found yesterday as an example is this: when a is equal to 5, right, n is equal to something like 4, something like that. Okay, so n is it cannot be that. Okay, we found an example yesterday. Let me look at the other one there. Okay. When a is equal to 4, all right, Oh man, it's getting really confusing. Okay, let's say a is 5 and x is 4. Okay, then fx it becomes e minus 3, which is about like zero point 0.3, which is quite close to zero compared to other cases. Okay. Um, so profit maximization point happens about here. This is 5 and this is 4. So the rectangle under this Z curve is maximized over there. Mhm. Let's intuitively think why that's the case. How come it maximization point does not happen in the middle point, kind of inflection point? Because I thought that's what it would be, but mathematically we found that it happens before A. Okay, this inflection point is A. Okay, how come it happens before A? Of course, if you go all the way down, then the uh this rectangle will shrink and become zero, right? And if you this x go to infinity, yeah, the rectangle will be very thin, so it will become zero too, right? So there is maximum measurement point, but it's not A, but it's below A, before A. Why is that the case? Well, my guess is that um, here you have concave. Is it convex or concave? Well, whatever. We call it convex, okay? You have convex curve, so the it goes like downward, right? Convex curve. So it's lower than straight line. That's why if you make area of this rectangle, it will be smaller, right? But up there, before A, you have uh, concave, concave curve. So it makes sense that maximization point happened before A. Mhm. Yeah. Now, And in this case, because x is equal to a minus n is equal to 1. Okay. I'm kind of wondering if A gets bigger, meaning we are shifting this Z curve to the right, all right? And then the profit maximization point from um, that's that profit maximization point will be a point where f becomes 0. Okay, so x is equal to a minus n, right? So if a become very big, yeah, n will become very big. So I was wrong. I'm correcting myself. I was wrong. Okay, a become very big, n will become very big. But a minus n, my guess is that it will stay pretty small. There's your a, and there is your x, which is the revenue maximization point, the maximization of this rectangle. And from here to here, a minus n, what is n? Well, here is your n. Because my guess is this, all right? I think n will stay pretty small, no matter how big a becomes, no matter how big x becomes. Hmm. I think it makes sense that my guess is this. Okay, so the profit maximization point it will happen like just before A, I think. Now, question is this a fixed number, or is this function of A, or is it some kind of constant? Right? My guess would be I think it should be the function of A. Uh, well, uh, so when this is zero, okay, X is the solution for this maximization problem, okay, because fx represents derivative of revenue function, okay, and this function is derivative of revenue function. So when the derivative is zero, that means that's the local maximum for the revenue function. Okay, so that x is revenue maximizing x, and um, all right, we're gonna grab another whiteboard, okay? Because if f and actually we can erase this guy because this is too easy, right? To calculate the inflection point, that's very easy stuff. So okay, a minus x equals n. All right, so x fx, well, whatever. F Fn is equal to f a minus x, right? Is equal to e to the n. Wow. Is it? I think so. You just plug in a minus x in there. Hmm. Well, I want to find this n, all right? I want to express this n in terms of way. I think it could be either function of a or a constant even, all right? How far away x should be from a to make this maximization point, all right? Yeah. And I think there it's always close by a, I think. No matter how far a goes, I think the maximization point happen like right before a. That would my guess. Okay. Now we want to prove it, prove or disprove that hypothesis. Okay. But that's my gut feeling. Okay. Yeah. Uh, we may have to expand that guy with not macro series, but Taylor expansion. Okay, using Taylor expansion. Uh, at least up to like second degree. All right, to keep things simple. Right, and then let's see what happens. Okay, so yeah. Okay, sounds like a good plan. Let's take 5 minutes break. Okay. Okay. There we go. Woo. Okay, let's grab a new whiteboard, shall we? That's going to be a challenge. Huh. What is this guy? Can I erase this? Uh, I think I can erase this one because this one is fairly easy. So I can always reconstruct this without difficulty. Yeah, we'll erase this one, okay? It breaks my heart, alright? But this is the pyramidal demographics, right? And then we integrate that and we found the profit maximization point happens A over 3. Okay, so I really don't want to erase this though. Oh boy. Uh, so your parabola, you multiply by x, right? I think I can erase this, alright? This, yeah, this is easy. I can reconstruct this with ease, so yeah, let's erase it. But it really breaks my heart. Yeah. But we have to. My heart is broken. Broken hearted. But I can always reconstruct this, so it's easy problem. Okay, now Taylor series. All right. Well, first Maclaurin series. Okay. Uh, is this e to the x is equal to uh 1 plus x plus. Let me grab myself one, okay? Because I don't want to misquote. Uh, okay. Taylor series. Yeah. Examples. Well, Maclaurin series. Okay. So, yeah, 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 yes. Blah blah blah. Okay. In general, fx is equal to. Well, we just to the most general case. Okay. Okay. Now, okay. Oh, wait a minute. Wait a minute. I'm sorry. I think it's just f of x. Okay. Yeah. Sorry. We just approximate with the second order. Okay. So okay. So this is that f prime x, f2 prime x. So this is f0x, okay? When we don't do differentiation. Yeah, we use this notation convention to denote the differentiation, okay? So, uh, okay. Now, then f of x is roughly equal to, put a there. Well, it zeroes out, right? Ah, put a here. Hmm? Mm-hmm. E to the 0, 1. Okay. And we are solving this equation, okay? All right. Yeah. Well, we're gonna have to expand it, all right? So, well, so you a squared plus 4a minus 2a plus 2. Can we factor this? I don't think so. So in this occasion, we have to use quadratic formula. Okay. Well, there's no other way. Okay. Now, what is x? What is fx? Okay, fx is the um derivative of revenue function. So when fx becomes zero, that x is the uh revenue maximization point. Okay, okay. And we know that happens before a. Okay, so this one has to be minus. Okay. Uh, so x is equal to, if we know a is more than 2, okay? When a is more than 2, when a is equal to 2, square root of 6, 4 minus square root of 6. Okay, okay, okay. So it actually is a slowly increasing function, all right? If x goes to infinity, okay, it's like a minus square root of 2 times square root of a, okay? If a goes to infinity, okay, then we can delete all this like plus 2 constants, right? So as x goes to infinity, yeah, this will be always positive, okay, because a grows faster than square root of a, okay, I think, all right? So uh, okay, so as x goes becomes very big, um, it seems Uh, all right. As a okay limit a go to infinity, okay, of x is equal to a, because all these guys they become zero, right? So actually, as we increase the x, a is the median income, middle income. How much money this person, middle income family make in the country, okay? As a go to infinity, profit maximization, it happens at a. X becomes a. So x and a, they are very tight. We got it. Okay. But it does change though. So it's not a constant. Okay. But we have some convergence here. Okay. So good. Convergence is some big deal. Okay. In mathematics, science in general, they use any mathematics. If you find some convergence, that means it's something really cool. Okay. And we got it. Yeah. We got it. I kind of suspected this a little bit. I thought the profit maximization point X is kind of like nearby A. Okay. Yeah. So when A is 2, I mean, when A is 4, no, when A is 5, is, A is 5, X is 4. Okay. When A is 5, so 7 minus square root of, when A is 5, 12. Yeah, about. Hmm? Hmm? Because in our calculation, when x is 5, a is 5, x was 4. Okay, this is close enough. Okay, it's 3 point something, something, something. Okay, good, good. It's a decent approximation. Okay, so, yeah, numbers add up. Yeah, when a is equal to 2, 4 minus square root of 6. Well, that's the positive number. Huh? When a is 3, 5 minus square root of 8. Still positive. Okay. The point I'm getting at is this bigger or smaller than a? Well, when a is 1, 1 plus 2 minus 2, that becomes, when a is 1, x is 1. Okay. When a is 2, x is equal to 4 minus square root of 6. That becomes less than 2. Okay. Makes sense. Uh, we're gonna find some room in some another whiteboard, okay? And then we calculate necessary and sufficient condition where x is less than a. I think it will be like the most of times, okay? It has to be, okay? Profit maximization point should be less than a, okay? So, and we'll prove that, okay? So, kind of Sam Walton principle a little bit, okay? And in theory, we know why that's the case. It's the curvature of the sigmoid function. I mean z curve. Okay, so is it downward curved or is it upward curved? Okay, so okay, we'll take 5 minutes break. Wow, yeah, this is intense. Yeah. All right. Oh, okay. we are onto something really good, really cool, right? Yeah. So kind of we are on fire in this mathematical land, which is good. Let's see what happens when a go to zero, which is a lot easier. Okay, a go to zero. Let me wash my hands real quick. Let me go to bathroom too. Ah, all right. I'm very excited about this. Right? Yeah, I've been having an adventure in mathematics land. Uh, so when x a go to zero, 2 minus square root of 2, which is 0.6 about when a is 0. Okay, okay. So let's make some room, all right? Let's switch out the board. We have a little bit of room over there in that whiteboard that I cannot erase because this is more than I can just reproduce easily. So I cannot erase any of this before I type them down in the economics paper. This is very much mathematical, but the mathematics we're using here is not that advanced mathematics. It's just second semester college calculus. That's all it is. Okay. And nowadays, yeah, about high school level, in some AP credit people, advanced placement, hardworking students. Okay, high school level for some high school students. Okay. All right. So we have some room here. Now, what we want to do is this. All right. We want to know when this guy becomes zero. A plus 2. Uh, what we want to, okay, x is equal to. Now, we want to find a point where this is less than a. Kind of Walmart principle, okay? X is profit maximization point. A is middle income people. Okay, so Sam Walton, his point is that if you cut the price, if you are your price is level is less than what middle income people can afford, then you maximize your profit. That's kind of one version of Sam Walton principle. Okay, so we want to find necessary and sufficient condition for this inequality. Okay, we know as a go to infinity, x becomes a. Okay, but most of times x is slightly less than a. Okay, and when a is zero, x is more than a. That means at some point it will be zero. X and a. Uh, yeah, there will be a point where they are equal. Okay, other than a going to infinity. Okay, so it's a little bit involved. Okay, so let's go ahead and equalize this guy. Okay, so and solve for a. Okay, all right. Oh, that's easy. Huh. Okay, okay. If a is more than one, then x is less than a. Okay. When a is equal to one, x is equal to a. When a is between 0 and 1, x is larger than a. Okay. And limit a go to infinity of x is equal to a. So Okay, we got it. We got it. That's it. Yeah, that's all there is to it. Wow. Uh, yeah. Wow. Yeah, it's circular logic a little bit because we assume that X is near A, right? So that's why we uh, conducted the Taylor expansion to the second order uh, around A, okay, to express exponential function in terms of uh, polynomial, second order polynomial, okay? So, yeah, we assume that X to be near A, but I think that's a reasonable assumption. Why? Because think about it, okay? You want to maximize this rectangle touching this z curve, which is flipped sigmoid function, logistic curve. And as this x shrinks, x move away from this inflection point A, okay? The rectangle gets smaller and smaller and smaller. It become very vertically thinner, right? But it's inflection point, so it's like upward curve. So profit maximization, the rectangle will be the largest somewhere around here. Okay? If x is more than a, the rectangle gets flatter and flatter and flatter. Okay? Yeah. When x is zero, rectangle area becomes zero. Right? When x go to infinity, the rectangle area becomes zero too. Where is our revenue function? Let's bring back our revenue function, okay, and then to see to verify it really becomes zero when x goes to zero, okay? Because uh ah boy. By the way, I found another whiteboard I can safely erase. That's a good news. That's our reference function, okay? So as x go to infinity, 5 is our a, okay? So yeah, e to the minus x becomes 0. So you have x minus x. Yeah, it becomes 0. Because infinity minus infinity type, right? So yeah. Hmm? But formally, how do you do that? Yeah, I found another whiteboard to erase, so let's formally do that stuff. Eh, we don't need that much room because this is easy stuff. Uh, let's make room here. We're claiming this will be 0. All right. Yeah, because x minus x is 0, of course. Right? Yeah, it is. Okay. Good. We're done. Wow. Mm, we got it. I'm just exhausted. That's all. Yeah, I feel good. Yeah, we got it done. Oh boy, there was something, huh? We got to the bottom of this. Okay. Very bottom, rock bottom. Okay, so now we can relax. Yeah, I think probably this will be the last mathematics I'll do in this economics paper. After that, we talk about economic cycle, right? Should we not have nothing to do with almost nothing to do with mathematics? Maybe some periodic function like sine curve, maybe circle, right? A little bit. Yeah, I don't think that would be necessary though. Yeah. Oh, oh, totally exhausted. Let's take a break, shall we? Then I grab my drink and we relax and we talk about something else. Okay, so oh my goodness, this is like I feel like I've been running for like an hour, right? Brain running. It's been 1 hour and a half, right? Totally exhausted. Yeah. I feel good. I'm just tired. Okay, that's all. Yeah, that's I recover in like 10 to 20 minutes from this mathematical fatigue. But we got it. Yeah, we got it. We got something. Oh, yeah. All right, let's take 5 minutes break, please. Oh, yeah. Let's celebrate, shall we? We came a long way, really. Oh, cheers. We are done with all the stuff. Okay. When it comes to mathematics for this paper, uh, that's where it's gonna end because it's more than actually not more than it's just the right amount of mathematics for this economics paper. Okay, so just right. But I'm not gonna go into this level of detail in this paper. I just give the result. Why? Let the future generation figure it out. Fill the gap. Okay. Like, do you remember when you were in school? Maybe you're still in school, which is cool. Okay. Or maybe you're too cool for school. There's this guitar brand. I had that one when I was in Madison, Wisconsin, I think. Okay. Too cool for school. That was the guitar brand. I think I bought it from eBay, I think. It was nice guitar. Right? It was blue guitar. Right? Too cool for school. Right? Good, nice rhyming. Because I'm sure those guitar manufacturers, they are guitarists themselves, right? Yeah. I'm sure they write like song lyrics and whatnot, right? Songwriters. Yeah, most guitar players, yeah, many of my friends are guitar players and they write their own music. Okay. I have many friends who play guitar. I can't. Yeah. So you remember back into that school, like you're taking some mathematics classes, right? And your mathematics teachers, they don't give you solutions right away. Okay, because they want students to solve themselves. Right? Even kind of like that. Okay, so I give out the result and let the future generation figure it out themselves. Okay, how they I got to this. Okay, I will not skip too much, but I won't go into this kind of detail. So if they want to understand, if they want the answers, they can come here and see how it came about. Yeah, this human series is kind of unique place in that we are discovering live. I mean, well, not this show is not live. It's like there's 1 day delay between recording and publication in this human series. Okay, but we are figuring out, discovering as we film real time, right? And sometimes I work it out in my notebook, pencil and paper, right? But most times we're actually doing it in real time. We're discovering things in real time, right? So that's what's really cool about this human series, okay? Because I don't know the result yet most of the times. We are figuring out at the same time together here, right? Yeah. Like science in the making, as opposed to just giving up the result, right? So there's something very unique about this human series, okay? It's a good education for future generation because they are witnessing how science is actually being made, the process. Right? Highly educational, right? How about me drinking? Is that educational? Well, how about this? Asian way of drinking culture, the right way. Okay, I'm not drinking and driving. No, drinking very slowly. I mean, for 1 hour and a half, I haven't been drinking at all. I just drank water. Huh? Yeah. But now it's done. Work and play. Now it's playtime. Let's enjoy. Relax. Right? And alcohol works to relax. Yeah. Wow. That was intense, wasn't it? I mean, the mathematics we used is pretty much like advanced high school level. right? Or just regular for second year non-mathematics major, college algebra, college calculus, right? Second semester calculus, that's what it is. Taylor series and whatnot, right? Yeah. Quadratic equation. I try to avoid the quadratic equation as much as possible, but this time we had to do it, right? Yeah. Which is fine. So, some another story. So Taylor series, Mr. Brooke Taylor, I think he was in 1600s, uh, Bernoulli's time, I think. Okay, 1600s. Euler, I think he's the next generation. I think he's 1700s. Okay, let me look him up. I don't want to misquote that. I'm pretty sure. Euler, Gauss, Gauss. Isn't he like 1800s? I don't know. Let's look them up. Okay, was Gauss contemporary of Euler? I don't know. Leonard Euler. What year? 1700s. How about Gauss? Carl Friedrich Gauss. Late 1700s. Okay, that's what I thought. About 1800s. Okay, so how about Bernoulli? Jacob Bernoulli. 1600s, right? Yeah. How about Brooke Taylor? Late 1600s. Okay, okay, okay. Yeah. So it's like this, okay? Bernoulli, Jacob Bernoulli, Brooke Taylor, Leonard Euler, and then Carl Friedrich Gauss. That's the lineage in European mathematics. Okay. Maclaurin, I think he was contemporary of Taylor. Okay. Early 1700, I think. Okay. So for a long time, Maclaurin, who learned from Brooke Taylor, all right, in Europe, Maclaurin, he was a prodigy, mathematical prodigy. For a very long time, for centuries, 200, 300 years, he was the youngest professor in college in England, well, in the world. He held that record for what, 300 years. He became college professor when he was a teenager, something like that. That record was broken like about 10 years ago, and it was a female American, Middle Eastern descent. Okay, yeah. She got Guinness Book record for being the breaking the record of Maclaurin, Professor Maclaurin. Okay, to be the youngest professor ever in human history. Okay, I do not recall her name. Okay, but I read her biography. Okay, she has her Wikipedia, of course, and article about her. Uh, the professor job she got when she was a teenager. It was in Seoul, South Korea, Konkuk University. Okay, yeah, it's a very good school. Mm. It's in Seoul. What's the university ranking of Konkuk University? I think it's top 20 in South Korea. That would be my guess. Okay, maybe top 10. I don't know. Well, let's look up best university ranking in South Korea. It's top 30. All right. Yeah. Yeah. It's a good school. Yeah. So she was professor there for a year. All right. When she was a teenager. What field? I think she focused on material science. Okay. Uh, yeah. Material science is very good field. That's physical science, right? Material science is very good science. It's like they deal with like materials like silicons to make semiconductors. Okay, that's one of many things that they study material science. Okay, but she didn't quite finish PhD. Why? I guess she was in her PhD career in what school? Some good school in America. Okay, I don't remember the name of that school, but yeah, good university, well known university in America somewhere. About 10 years ago, I think. Okay. So she was doing PhD and she sued her professor, okay, for plagiarism, for basically stealing her ideas. Okay. So basically she dropped out of PhD program. Okay. Later on, she became a lawyer, intellectual property lawyer. Okay. Yeah, so it became her passion, intellectual property protection, because I mean her lawsuit settled arbitration. Okay, I read an article about her because she's Guinness Book record holder, becoming the youngest professor ever, right? And she's American of Middle Eastern descent, and she was prodigy, right? Yeah, cool. Yeah, hmm, yeah, that's cool. Well, I kind of see some similarity between she and me. I mean, I'm no prodigy. I when I was in school, I was just chugging along until like eighth grade. Right, from eighth grade and on, yeah, I did very well in school because I took it seriously. Okay, but when I was in law school, I was chugging along again. Okay, but I did graduate, and it was top 10 law school, Michigan law school. Okay, but I kind of chugged along. I didn't pay. I did pay attention when I was in class, but at home I was more busy like going to dance clubs and okay, learning how to dance and stuff. But I'm also PhD dropout. Okay, she didn't finish her PhD, and she changed her career track and she became a lawyer, intellectual property lawyer. On paper, I'm also patent lawyer too. Okay, I'm also PhD dropout as well. So and but she was prodigy. I was not. No, I struggled. Okay, I was not prodigy. When I was in middle school, elementary school, mathematics was very difficult for me. I struggled. Mm. It was not easy. But I worked very hard to learn mathematics when I was in eighth grade and on, and I became very good at it. But it was not like I was some kind of prodigy. No, it was very struggle. Also, spending a lot of time with my colleagues and teachers, professors, some of my own family members to learn from them. And they taught me very well. They were very kind and generous. Okay. Many people who taught me good mathematics. In South Korea, South Korea, and also in America too. Okay. Yeah. So, but yeah, I dropped out of PhD. So what? I learned a lot when I was in PhD for 2 years. Nothing was lost, wasted. Okay? Yeah, got good education. After I dropped out of PhD, I'm still studying economics, mathematics, physics. I'm still learning and also discovering something new to the world. After I discover these things, I write them down and to share it with the world. But you get the first scoop though. Why? Because I need to brainstorm, organize my thoughts. Then it gets written. Then other people get to see it. But you get the first scoop though. You know? I mean, other than myself. Okay? Actually, many times I discover right here, like those mathematics we did. Okay, so there's just 1 day delay between me discovering this, I film this, and I publish it next day. Okay, so it's pretty much near the same time. Okay, so yeah. So this lady, okay, she may be about my age. Okay, I don't know. Okay, prodigy lady. She was disillusioned about academia. Okay, PhD career. She wanted to be a professor, right? And she became a lawyer instead. Was I disillusioned when I was in PhD? No. Then why did I drop out? It's the same reason I dropped out of special forces. It was too much for me. I could not take it. I admire people who make PhD. Many of my friends even become professors after their PhD. Okay, I admire them. I couldn't do it. They did. I couldn't. It was beyond me. Okay, yeah. I admire people who finish their PhD. Okay, they're cool. We'll take 5 minutes. Okay. Yeah. Yeah, I recovered from my fatigue, so yeah. Okay, can we talk about school bullyism? I'm sorry, it's difficult topic to talk about. We've been all bullied before. Yeah, it's uncomfortable topic to talk about, but hey, welcome to humanology. Anything goes, okay? We talk about things that people would rather not talk about, okay? That's one of the things that we do here. Okay? We have substance, all right? Yeah, we don't shy away from topics that's difficult to talk about. Actually, those challenging topics to talk about, those are our favorite topics here, okay? I had this dream, okay? So in this dream, I saw this guy, and he was one of my school bullies. Okay, back in middle school days. We talk about early 1990s. Okay, he and I later on we became friends. Okay, why? I mean, when I was in seventh grade, yeah, I was bullied upon by two guys. Okay, later on we kind of became friends. Why? When I was seventh grade, there's four. South Korea back then. I don't know how it is now. Middle school 3 years, high school 3 years. In America, middle school 2 years, high school 4 years, right? But in Korea, it's three and three. 3 years middle school, 3 years high school. Okay. So when I was in seventh grade, the first year of my middle school, yeah, I was bullied by two guys. Okay. Later on, we kind of became friends. Why? Because I became a man. Okay, and I became very diligent. But in seventh grade, I was lazy. I was a lazy student. Okay. I was weak. So I kind of deserved that fate. When I was in elementary school, I did bully upon, I did bully, okay, when I was in elementary school, all right? So I was getting the taste of my own medicine. What goes around comes around, right? Kind of karma. I deserved that fate, okay? So, but after seventh grade, when I become eighth grade, this experience of bullying during the seventh grade by two guys, uh, it disciplined me and it made me stronger and smarter. It also drew me to mathematics, study in general. It made me more diligent person. Okay, and also it drew me closer to Christianity because I asked God for help. Okay, because I was there was nobody to turn to. Okay, when I was bullied up on seventh grade. Okay, I could not tell nobody why. I had my pride as a boy, man, young man. Okay, so no, I can tell you because I was ashamed. Okay, so eighth grade, yeah, also it drew me back to Taekwondo. Okay, so yeah, eighth grade, restarted doing Taekwondo, became very serious about Christianity, religion, right, and became very serious about studying. So I grew my strength by diligence, and all the bullyism stopped because bullies they pick on weak weaker guys, smaller guys, right? And I grew my strength by diligence. Serious about Christianity, studying, and martial arts. Okay? Yeah. Yeah. So school bullies, they're kind of like drill sergeants. When I was in the U.S. Army, okay, drill sergeants, they joked about their profession. Hey, we are getting paid for being mean and rude to our soldiers. What can be better than that? That joke to us, okay. We are getting paid for being mean and rude to our soldiers. It's just a joke, okay? So it's about discipline, okay? So school bullies are they're kind of like drill sergeants, right? But we don't condone bullyism. We don't condone any form of violence, okay? I mean, it turned out to be a good discipline for me and for some others too, okay? Yeah, but there are other ways to discipline people, like in basic combat training, they don't touch us, drill sergeants. No, they yell at us, but no touching, okay? when we do something wrong, even when we didn't do anything wrong, they yell at us to discipline us, yelling, okay? Or yeah, make us to push up, sit up, do my run, okay? Yeah. Or bathroom detail, clean the bathroom, right? Yeah. So yeah, there are ways to discipline people without touching them, okay, physically. Why? Because school bullyism, is it a crime? Yes. What crime? Misdemeanor. What kind of misdemeanor? Criminal battery, unwanted touching. Is it suable in civil court? Yes. Intentional infliction of distress, emotional distress, IIED, intentional infliction of emotional distress. Yeah, they can be sued in court. School bullies, okay, and they can be charged with some criminal misdemeanor too, criminal battery, assault. Okay? They are crimes, and we don't condone crimes. Okay, so yeah, school bullyism, yeah, they are crimes. Okay, so they better school teachers better educate those children. Okay, because they are if they are bullies, they are committing crimes. At least they can be sued in civil court. Intentional infliction of emotional distress. They better teach their children in school. Okay. Yeah. Okay. So, so in this dream I had last night. Okay. Yeah. Just one of just two bully guys. Okay. Later on, we became friends. Okay. The other guy, yeah, we kind of became acquaintance a little bit. Okay, but not quite very close friends. Okay. But the other guy, yeah, he and I, we kind of became friends because we met again in high school about 2 3 years later. Okay. Yeah. Yeah, we kind of became friends. I mean, not very close friends, but mutually respecting kind of friends. Okay. Yeah, we did. What happened in this dream? We are still friends. Okay. Yeah. Yeah, that was interesting. Whatever. Yeah, I forgive and forget. Okay. I used to bully too. Okay, when I was in elementary school. It's just boys being boys. Okay, it's just growing experience. Okay, it's no big deal at all. No, no big deal. No big deal. In my opinion, okay, it's God's scourge. Okay, everything happens for a good reason by design from God. Okay, Book of Psalms, I think Shepherd David. Okay, later King David. He said, "Yeah, God disciplines, punishes those that He loves." Because when we go through hard times, we could become stronger and smarter. Okay, so and that's how it happened in my life. Mhm. Yeah. So so that's that. Okay. So when it comes to Hollywood, it's very elitist institution, Hollywood, right? I dropped out after 2 years. 1 year, I was an actor. Second year, I was a filmmaker. Okay, I dropped out after 2 years. Hollywood. Why? It was too much for me. Okay, I couldn't take it. Okay, yeah, and at the same time, I kind of fed up. Okay, yeah, acting, I did that. Filmmaking, I did that. After that, it's enough of this entertainment business. So I wanted to do something else. So I joined the U.S. Army. Okay. PhD career, same thing. Yeah, it was too much for me, but at the same time, I did not want to do that anymore. Okay, I had enough of higher education by then. I dropped out of Cornell University, Ithaca, New York, in 2006. Okay, after 2 years, right? Because I had enough of that. Okay. Special Forces, U.S. Army, very highly an elitist institution, right? I dropped out after 2 weeks. Well, but before I went to Fort Bragg, North Carolina, I trained for the selection course 3 weeks in hell for a month, about 2 months or a month and a half. Okay, so I dropped out after 2 months, kinda. Okay, well, first I couldn't take it anymore. Second, I had enough of that. Okay, so yeah, so I came back to Fort Hood, Texas, and then we deployed to Afghanistan. Isn't it romantic? Yeah, good old days, right? Yeah. Some army stories? Yeah, after 5 minutes break. Okay. I tell some interesting stories. We'll take 5 minutes break, okay? So, okay. Yeah. Alright. So, yeah, whenever bad time comes, you should take advantage of that. Okay? Obstacles, setbacks. Like, last, last year, when I lost the election, Alaska State Senate race. Primary, Republican primary, okay? I started writing. So yeah, it's like Phoenix concept, right? Resurrection. Yeah, I failed in politics, right? So something's gotta give. Let's like in good old Bible, right? Book of Genesis, Joseph, when he said to his brothers, who sold him as a slave to Egyptians, okay? Yeah, God turned curse into blessings, right? So I lost the election, right? I was the very last place out of 7 people. I got the least votes. Other candidates 3 times, 5 times. I got 110 votes, and God bless them. Okay, I'm very grateful. All right. But other candidates like 300 votes, 500 votes, 1,000 votes. Okay, Yeah, I was at the very bottom. I'm very grateful to 110 voters who voted for me. Yeah, God bless them. Okay, eternally grateful. But at the same time, yeah, uh, just losing the election big time, being at the very bottom. Okay, yeah, it did hit me pretty hard. Okay, so I started writing. Yeah, voters equation is about humanological analysis of election. Okay, yeah, good stuff there. Okay, yeah, transformation, conversion from curse to bless. Negative copium, positive copium. Okay, minus plusism, minus and plus. Okay, yeah, taking advantage of obstacles, setbacks, hard times, hardships. In 2021, anti-Asianism. Okay, because Americans are blaming, it's not all, like 0.01% of Americans are blaming Asians for COVID-19, like President Trump, right? Calling China virus, Kung flu, whatever, okay? I wrote an essay about it, okay? Yeah, yeah. President Trump, back then, his job is to solve this problem as opposed to pointing fingers, okay? Blaming somebody, okay? Because AIDS came from America, San Francisco, okay? But nobody called it American virus, right? Or LGBT virus. Oh, right? We should not point fingers to America, San Francisco, LGBT community. No. Okay. That's very immature response. Okay. President Trump, yeah, editor cartoonist, he described him as a baby and yeah, whatever. So when anti-Asianism happened, okay, racism against Asians, bullyism against Asians, okay, yeah, I stopped watching the news. I stopped social media and I focused on Wikipedia instead, mostly, or some other websites, okay, to learn about human history, literature, right? Yeah, taking advantage of obstacles, setbacks, hardships, right? Very intellectually enriching experience, okay? And it's more intellectually, more entertaining than reading the news, okay? 99% of the news that we watch nowadays, it will disappear in 10 years. Okay. 99% of celebrities that we see today in the news, on television, movies, TVs, they will all go away in 10 years. Okay. But human history, those are the very best who survived test of time or time and space after they are long gone. History, right? Is by far more entertaining than watching today's news, TV shows, movies. Okay, let's talk about news, movies, TV shows. Only 1% of them survive and become eternal. All the others, they get forgotten and buried. All right. So when we watch today news, TV, movies, only 1% of them survive eternally. But when we look back in the human history, the survivors of who withstood test of time and space, they are the very best, the eternals, not ephemerals. Okay, when we read the history books, those are the ones, ideas, stories, events, works, products, music, movie, painting. Only the very best survive. Okay, evolution. Okay? survival of the fittest. Oh? So when we deal with history, we are dealing with eternals of hundreds of thousands of hundreds of years ago, thousands of years ago, right? It's a higher quality because they are the survivors, metaphysically speaking, okay? As opposed to we read contemporary news, music, TV, painting, whatever. With 99% will just go away. They're ephemerals, as opposed to eternals from the old past. So yeah, I discovered this. I'm sharing with you. Okay. Yeah, learning about history, we're dealing with the eternals. Higher quality by far. Okay. Who are those people who leave their marks in human history, who become eternals? They are the ones who went through very difficult times, okay? Survivors. Right? Mind process. Right? They went through very difficult times in their lives. And they came up with very good stuff because they are disciplined. They are like gold miners, right? Yeah. Dig deeper, harder, right, to mine these gold nuggets, right? Well, it's not like that, actually. Yeah, gold is kind of mixed with mud. It's barely visible. They're oxidized, maybe, okay, so muddy and stuff, but they gold miners, hardcore, disciplined. Okay, they dig deeper, deeper, deeper. Okay, they find the gold and bring it from underground to the surface level. Right, they sell it. Huh? And they become rich. Oh, so kind of metaphysical analogy here. Okay, yeah, mathematics. We dug deeper, deeper, and deeper until we reach this rock bottom. That's what we did about an hour ago, right? Yeah, we did that. We reached the rock bottom and we stopped. We got to the bottom of that thing, all right? Yeah, I mean, would this translate to some money? It might, right? Yeah. If not, that's fine too. Because personally, I don't need money. I have my job. I pay my bills. This we do for fun. It's like video gaming, right? Or stock market, investment, gambling, okay? Entertainment, like gambling. I've been to Las Vegas. It was fun, okay? Yeah. I went to some casinos when I was in Los Angeles, California, okay? And in one, I think it was blackjack or slot machine, I earned like $20 and I felt sorry because when I gamble in a casino, I'm having fun. I'd rather lose money. Why? I want to pay for the entertainment value that I got, give and take. So when I earned $20, I felt sorry. Okay, what did I do? I went to a restaurant in that casino joint establishment building. I stayed there, went to restaurant. I spent $20 in that same building in the restaurant casino because I want to pay for this entertainment. Okay, no, I don't want to. I did not want to take the money. No, it was $10 about. Okay, I wanted to spend that money there because I had fun of winning this blackjack or whatever. Okay, slot machine. I wanted to pay for the entertainment value. They gave something to me, happiness, blackjack winning. Okay, I want to pay for it. To be fair, so yeah, I spent all that money in the restaurant, eating some dinner, right? Outskirts of California. Okay. Los Angeles. Yeah, and I did. Yeah, spent all the money from gambling money, about $20. Okay, I spent it all, every single penny. Okay, yeah, we take 5 minutes. Okay, some story time, right? Yeah, we take 5 minutes. Okay. All right, all right. Okay, some interesting army stories. You like this, okay? You like this. Interesting army stories. So, I joined the US Army when I was 31. That was back in 2009, 12 years ago, right? Uh, I was born in 1978. So by 2009, I was 31 years old when I joined the US Army as a junior enlisted soldier, E4 specialist. Why? Because I have college degree. Okay, so yeah, they gave me E4. Okay, yeah. But when I was in basic combat training, Fort Benning, Georgia, home of infantry, I was not infantry. I was helicopter electrician. Okay, electrician for helicopter. Yeah, avionics. Okay, so uh, but I was trained very well in Fort Benning, Georgia, all boys school, Canada. Okay, before that, I was in Seoul, South Korea. Good training, Spartan type. Okay, brain, brawn, and brute. BBB, Better Business Bureau. Okay. Bravo, bravo, bravo forever. Okay. So Better Business Bureau. Okay. Yeah, I'm brown too. Yeah, I'm trying to rhyme. Kind of naturally. Yeah, it became my second nature. Okay. I learned some hip hop. Okay. Rapping style. So. When I was in Afghanistan. Okay. From my friends. Okay. So basic combat training. Okay. Army boot camp. Okay. Before that, I was in South Korea. Good training. Good discipline. Okay. We were physically corporal punishment. Okay. They would carry this wooden sticks, right, and punish us on the thigh, calf. Okay, we are in the push-up position. Okay, and then butt, thigh, calf. Okay, or hand, arm. Okay, yeah. When we did something wrong. Okay, and I was frequent flyer. Okay, because I was troublemaker. Okay, maybe maybe I still am. Okay, because I'm going against Alfred Marshall, Sigmund Freud, Karl Marx, Albert Einstein. Yeah, I'm still troublemaker. Okay, very rebellious. I went against Immanuel Kant as well. All right, in those papers I wrote so far. But metaphysically speaking, okay, so whatever. So yeah, so basic combat training, then AIT, advanced individual training. Okay, then I was stationed in Fort Hood, Texas, Killeen, Texas. Fantastic town. I love Texas. Killeen, Texas, Copperas Cove, Hyco Heights, Belton. Okay, great towns. Okay, in and about. Right, they're fantastic. Okay, so I graduated from BCT and then AIT Army schools. That took me about 1 year, 9 months, something like that. Okay. Then I was stationed in Fort Worth, Texas. Okay. And there are these soldiers who came back from Iraq, Iraq deployment. Okay. Yeah. So they are combat veterans. Okay. Combat patch, right? And I just graduated from AIT. Okay. Fourth station, Fort Worth, Texas. Fourth and last. Okay. I was in the US Army only for 4 years. Okay? But by then I was like 32 years old, 2010. And the guys, army soldiers who just came back from Afghan and Iraq deployment for a year, they came back, okay? And they were younger than me, most of them. But they've been in U.S. Army for like 2, 3 years. Me, I was green, new to U.S. Army. So there's some seniority, right? Seniority going on. It's kind of individualism, okay? I'm older than they are, they're younger than me. But in the U.S. Army career, they've been in U.S. Army old more years than I did. It's a minus plus plus minus, okay? So dualism, okay? And so they're younger than me. They were like in their mid 20s, late 20s. Some of them even all early 20s. I was in my early 30s. So I was older than them, but they have more seniority in U.S. Army organization because they joined the U.S. Army several years before I did. We all specialists, E4. Some of them maybe E3, E2, E1, I don't know. But we are all junior enlist soldiers, but they've been in the U.S. Army longer than I did. Okay, and they deployed to Iraq. We are talking about 2010, right? Yeah, they just came back from Iraq. Okay. So they are decorated junior enlisted army soldiers with combat patch. Me, just graduated from army school after 1 year. They've been in the U.S. Army for 2, 3 years, right? And they are younger than me. I was older than they were, but they had more seniority in U.S. Army organization. Okay, so some of them decided to pick on me. Okay, and I did not let them. Why? I was like, you guys are younger than me, and yeah, you deployed to Iraq. You came back. Well, thank you for your service, but I'm in the U.S. Army too. Yeah, I'm kind of green and young. I don't. I have juniority in U.S. Army because I joined the U.S. Army like year ago. You guys 2, 3 years ago, but you are younger than me though. I have been in on the planet Earth more than you have, and I'm not gonna let you bully upon me. No, why? When I was on my teenager in Seoul, South Korea, middle school, seventh grade, I was bullied upon for a year. Okay, and it was bad. Okay, and later on, I learned my lesson. Okay, yeah, I have to be diligent. I have to be disciplined. Okay, Christianity, mathematics, martial arts. Okay, so you guys are what mid 20s, like 25. I'm 32. You're 25, 27, or 21, whatever, 23. You guys are younger than me. Okay, you've deployed to Iraq. Thank you. Okay, but you have to understand this. Okay, when I was a civilian, it's like every day is war. You go highway, drive in the highway. Every day you go to work. I was a computer programmer, and I did that in Los Angeles, California. Right? Every day you go to work on the highway, driving your car, you risk your life as a civilian. Okay, so every day is a war. Yeah. So being a civilian is like going to war every day. Okay, so yeah, you're combat veteran. Yeah, congratulations to you coming home safely. Okay, and thank you for your service. Okay, but uh, you are like 27, 25, 23. I'm 32. I live longer years on planet Earth than you have, and I've been through many difficult things. When I was in South Korea, in seventh grade, when I was like 13 years old, I was bullied for a year. Okay. And I'm not going to get bullied anymore. Okay. Because I've been through that stuff already. And I don't repeat my history. Okay. I'm 32 now. when I was 13 years old, I was bullied for a year. After that, I worked very hard, studied very hard, and I believed in God, Christianity, went to churches. Okay, I have been very diligent, so I don't deserve yet another bullyism by younger guys. No way. And on top of that, I learned a lot of martial arts too. Okay, I'm 32. You're like 27. You may be like some muscular guys, right? You may be some high school football star when you were in high school, right? You know how to tackle, how to wrestle, right? Guess what? You're like 27, 25, 23, right? Yeah, I'm 32, right? And I learned many different kinds of martial arts from my friends. Okay, I was ready to fight them. Okay, so they backed down. I was ready to fight them. I was okay. So because I'm not gonna tolerate that bullyism by younger guys. When I was 32 years old, when they're like 27, 25, 23, yeah, they got more muscle than I did. They know how to tackle. They're American boys of all different races. Some of them, like Hispanics, African Americans, Caucasian Americans, Hispanics, okay, they try to pull up on me. No way, man. No, I fight you. And they stopped. They backed off. All right. Later on, we became friends. Very good friends. Okay. Yeah, it's just guys. Yeah, try to punk each other out. Okay, we guys we do that. I cannot speak for women. All right, but we guys, that's just how it goes. Right? In the animal world, yeah, bullfighting, right? Yeah, these bisons and deers, all these male animals. Okay, they try to gauge each other's strengths. Okay, yeah, it's just male things. Okay, guy thing. Yeah, later on we became good friends. Okay, so yeah, interesting. I don't know what your gender is, but I'm a man, right? I grew up as a man, right? I cannot speak for women. I don't understand women at all. Okay, that plumb. They say yeah, women are from Venus, men are from Mars, right? Women, they like, do women understand men? I don't think so. Do men understand women? I don't think so. We are plumb different, really. Like we are two different species, right? I can only speak for men. Okay, yeah, that's just how I grew up. Okay, between us guys, yeah, it's just the way it is. Okay, we guys let boys be boys, kind of thing. Okay, so yeah, that's just how it is. Okay, we guys, yeah, we challenge each other, and later on we become friends. It's very muddy, dirty, right? Yeah, that's how it is with between us guys. Okay, so okay, it's almost 3 hours now. Okay, yeah, so We stop here, all right? With some mathematics, right? Yeah, that's good, right? Yeah. After it's done, okay, we hit the rock bottom. Yeah, this we did enough of that. Okay, so yeah, this there we as far as mathematics goes in this economics paper. Okay, yeah, and after that, yeah, I started drinking and now I'm drunk, as you can tell. Okay, I have Korean accent, and on top of that, when I'm drunk, uh, I'm slurring, so it will be very difficult for you to understand my English. But Google YouTube has fantastic just language voice recognition software or whatever, artificial intelligence, neural network. Okay. Great. They are turned on closed caption, subtitle. Okay. I won't get offended. Yeah. But I'm pretty sure you can understand my English. Okay. 99% of Americans, they understand my English. Okay. So even when I'm drunk, on top of my heavy Asiatic accent. Right? So they do. Okay. Yeah. We have 3 minutes left. So after the episode, humanized episode, I typically watch a movie or TV show from DVD or Amazon Prime or Google YouTube, some documentaries. Okay. Yesterday last night I watched this wonderful documentary about Mountain, Cut My Island, Grizzly Bears. Okay. It was very beautifully filmed. Okay. There's some ideological portion, in my opinion. Okay. About climate change, alarmism, whatever. But Katmai Mountain has a big volcano about 50 years ago, right? I mean, when it comes to climate change, okay, human beings, carbon dioxide, fossil fuel, oil and gas, okay, it's very minuscule compared to natural disaster like earthquake or meteor, or like cataclysmic volcano, okay? Compared to those natural climate change, volcanoes, meteor, or all those things, okay, human causing this carbon dioxide compared to natural disasters, human causing fossil fuel, that's like minuscule, that's nothing. Carbon dioxide, plants love it. Carbon dioxide, fossil fuel, plants love it. It's their food. Okay. So I'm against this climate change alarmism. Okay. Human being, yeah, fossil fuel, oil and gas, there's very minimal impact on environment. Okay. Natural catastrophe like volcanoes, meteor from outer space or things like that. That's by far bigger change. Yeah. Dinosaur they get extinction. Okay. It could have been volcano, it could have been meteor, who knows? But I have some doubt about that meteor theory. Okay. I think it was a group thing. Whatever. But human causation of this fossil fuel oil and gas, I think that's very minimal. Okay. I don't think it's not nearly as big as volcano, earthquake, meteor, right? Yeah. Compared to those natural causing extinction like dinosaur extinction. Human causing oil and gas, I think that's very minimal. Okay. That's my opinion. I'm conservative. Okay. Whatever. All right. Have a nice day. Thank you. God bless you. Bye.